Hey guys, welcome back to my channel, The Math Pad, and today we're going to do some questions on bearings. Before we dive into the questions, I would like to go through some basics for bearings so that it's more clear when you do the complicated questions. So if you look at the diagram that I've drawn on the right-hand side, let's say in a question you're asking us to find the bearing of B from A. Bearing of B from A. So that means we will look at the bearing from A. This is where we're focusing. Now you need to remember is that the bearing is always measured clockwise from the north. We will go in the clockwise direction from north. So that means when we start from the north at A, this is the angle that we're focusing on. Okay. So if, for example, in the question they've told us that this angle over here is 35, just assuming this is 35, and they want us to find the bearing of A from B. So you need to remember that when we're talking about the bearing, firstly, the bearing will always be measured from the north, and it was going to be in the clockwise direction. Secondly, we write the bearing in 3 digits. Like, for example, if it was 45, 45 would be written as 0.45 degrees. So that's how you write the bearing. It's always written as a 3-digit number. So going back to this diagram, if this is 35, this angle over here would also be 35. The reason being is that when we have two parallel lengths, alternate angles are equal. So if the lengths are parallel, alternate angles would be equal. Hence, this 35 is the same as this 35 over here. And the first quadrant, each quadrant like equals to 90 degrees. So first quadrant also equals to 90 degrees. Hence, when you find the bearing, your bearing for this particular question would be 90 plus 85, which is 125 degrees. So that's basically how you find the bearing for like any question. So if you look at the question that is given over here, it says helicopter flies from its base to deliver supplies to 2 oil rigs at C and D. C is 6 kilometers due east of B, and the distance from C to D is 8 kilometers. D is on a bearing of 120 from B. If you look over here, it says the bearing of B from B. So we look at point B, and the angle that this line makes with respect to B is 120, and it's measured in clockwise direction from north. So they want us to calculate the bearing of B from C, which means since it is from C, our main focus compass is going to be over here. And this is the angle that we need to find. So in order to find this angle, what we need is we need the angle inside the triangle. Because obviously we don't have any other angle, and the 120 also cannot be used in this case because like there are no alternate angles over here. Since there is no other line going from C, like in the left hand direction. So it's ideal that we try to find the angle inside the triangle. So to find the angle inside the triangle, we need to use a formula. So the formula that we will use will be based on the formulas that is used for finding angles or lengths for a non-right angle triangle. So for non-right angle triangles, We can either use the sine rule or the cosine rule. But there are also conditions for that. So for us to use the sine rule, we need two sides and the angle between them, or you need all three sides should be known. Whereas when we talk about the sine rule, you need one angle and side pair to find the unknowns. Uh, in our case, if you look at the triangle, we do not have all three sides. We do not have one angle and its corresponding angle. However, we have two lengths, but we don't have the angle between it as well. However, if we look at this angle over here, we can find this angle. This angle would be 30 degrees. Reason being is that the first quadrant, like not the first quadrant, every quadrant is like, 90 degrees. So if we subtract 90 from 120, that gives us angle BBC is going to be 120 minus 90, which is 30 degrees. So that gives us an angle. So now what we have is two angles and, sorry, two lengths and one angle. Now, when I was talking about, one angle and one side pair, I'm talking about this. Over here, we have one angle and side pair. When I say one angle side pair, it means that if we have, for example, a length which is 8 kilometers over here, its corresponding angle would be the angle opposite to it, which is angle B. Similarly, for the length BC, its corresponding angle is going to be angle D. Then for your length BD, your corresponding angle is angle C. So this is how you make a pair. Each length has a pair with the angle opposite to the length. So keeping all of that in mind, since we have one complete pair, which is for this angle and this length, so we can use sine rule. Now, what is the sine rule? Sine rule is basically A over sine of angle A equals to B over sine of angle B equals to C over sine of angle C. So the small ABC represent the lengths and the capital ABC represent the angles. So what we're going to do is, since we're going to find the bearing of D from C, but first we need the other angles, so we can find this angle. Why we can find this angle? Because we have its corresponding length. So it's ideal to go for what we already have. So what I'm going to do is I'm going to write 8 over sine 30 equals to 6 over sine D. Now, you must be thinking why I'm not writing the third fraction. The reason why I'm not writing the third fraction is because we don't have any value for it. And when we're trying to find an unknown, we only need two fractions. We don't need to use the three fractions in one go. So it's always ideal to first write, whatever information is known, and then pick the fraction that has one known and one unknown value. Find the unknown value basically. So we have the two fractions. We cross multiply 8 sine D equals to 6 times sine 30. Sine D equals to 6 sine 30 divided by 8. So we just plug in the value in our calculator, and that gives us 6 sine 30 divided by 8 is 0.375. So what we're going to do is we're going to find the value of the angle by taking sine to the other side and making it sine inverse. So sine inverse of 0.375 will give us 22.02. So 22.02 is this angle here. Now we can find the third angle by subtracting 30 and 22.02 from 180. Reason being, sum of the angles for a triangle equal to 180. So 180 minus 30 minus 22.02. That gives us 127.9. Now, the question was asking how to find the bearing of D from C, which is basically this angle. So when we have this angle, which is 127.98, why don't we subtract this angle from 270? Because we're covering 3 quadrants, and 3 quadrants basically equal to 270. So if we subtract this from 270, that would give us the bearing. So 270 minus 127.98 equals to 142.0. That is your bearing. So basically throughout this question, we applied the sine rule, then we applied the concept for sum of angles for triangle, and then concept of bearing. If we look at question number two is basically asking us to find, it says AOC is the diameter of the circle, center O. AT is a straight line that cuts the circle at B. PT is the tangent to the circle at C. Angle COB equals to 76. Calculate the angle ATC. Okay. So we have this angle 76. We know this angle would be 180 minus 76, which is 104. Angle is 180, 76, 104. Now, center is O, and the points A, B, and C all lie on the circumference, which means AO is the radius, BO is the radius, and CO is also the radius. So all of these lengths equal to the same quantity. Since AO and BO are the same, which means this is an isosceles triangle. So if it's an isosceles triangle, we can easily find angle A and angle B, which would be 180 minus 104 divided by 2. Which will give us 38. Now this is 38, this is 3. Calculate ATC. Now ATC is left. PT is the tangent. So the angle at C is going to be 90. So angle ATC will be 180 minus 90 minus 38. which is 52 degrees. So 52 degrees is your angle for AC. Then it says T is due north of C. Calculate the bearing of B from C. Calculate the bearing. Draw our compass and C. And this is where B lies. Calculate the bearing of B from C. So we start clockwise from, and this is the bearing. So basically, what we need to find is the angle inside the small triangle. So for that, once again, we use the concept of isosceles triangles because PO and OC are also the radius and they're equal to each other. So to find OCB, we'll do 180 minus 76 divided by 2. So that's going to be 52. And bearing will be 270 plus 52, which will give us 322 degrees. Yeah, that is your bearing of B from C. Question 3 says, a plane flies from Auckland to Gisborne on a bearing of 115 degrees. The plane then flies on to Wellington. Angle AGW equals to 63. We have to calculate the bearing of Wellington from Gisborne. Bearing of Wellington. Obviously, we draw our compass over here. And start measuring from the north, clockwise direction. And this is our bearing that we need to find. We know that we have this angle, we have these two lengths, we have the bearing over here of 150. What if we do, we can find that angle, yeah. We can find this angle once again using the sine rule, which would be 400 over sine A equals to 410 over sine 63. So cross multiply 400 times sine 63 over 410 equals to sine A. Plug in the values in the calculator. So that's going to be 400 sine 63 divided by 410, 0.86927, take sine inverse. So sine inverse of 0.86927 gives us 60.37 degrees. So this value over here is 60.7, and you can find the third angle. So 180 minus 63 minus 60.37, 56.63. write that over here as well. Angle AWG minus 63 minus 60.37, 56.63 degrees. Okay. So now that we have the angles, we know that alternate angles are equal. So which means if this is 115 over here, this is going to be 115. Let me just put it over here. 200. So if we do 180 minus 115, that's going to be 65. Yeah. So your bearing will be basically 360 minus 65. Yeah, minus 65 and minus 63. Because this pink angle is what we're trying to find. For that, we get rid of the 63 and 65. So that is going to be 360 minus 65, 232 degrees is your bearing of W from G. Yeah. Then if you look at part B, the distance from Wellington to Gisborne is 400. Yeah. Calculate the bearing of Wellington from Auckland. Okay. So now our compass is going to be at so Wellington. Okay, so it's the entire. So yeah, we already found the angle. So it's basically what we did in part A for sine angles. That bearing is going to be 115 plus 60.37. That is 175.37 degrees. Put it 140. Yeah, that is your bearing of Wellington from Auckland. If you have any questions or confusions about any of these questions that we've done or concepts, just let me know in the comments below and I'll help you out.